guess that a lot of people, when they were younger, went to the beach and made sandcastles. First of all, you need a bucket. And the first thing you do after mum and dad have bought you that is run onto the beach and try and make a sandcastle as quickly as you can. When you first go on the beach, you're up a long way from where the sea has been, and the sand is very dry. It doesn't really make very good sandcastles because it just pours almost like a liquid. So after a while you run down by the sea where the waves are coming up and you try again, but that sand is too wet and you find that it sticks to the side of the bucket. But between the two sides of the beach, you'll find the sand that's just right, where it's bound together with water so that it will form a perfect sandcastle. They always have a slope on the sides. The reason for that is once you've filled it, you give it the customary couple of pats, that releases the bucket and then it will lift cleanly off the sand. Rather than using water to bind the sand together, this sand is bound with oil so that it will bind together and hold a shape really well. Using oil means that we can use a finer grade of sand, which will give a better quality of casting. We're going to make our sand mould in a metal box known as a flask. This is a two-part box which has locating pins so that they can be taken apart and locate accurately each time. The top is known as the cope, the bottom is known as the drag. Today we're going to make two products. The first one is a small cylinder or bearing block, and we'll use sand moulding to produce that. The second product is a small coin, a supermarket trolley, so that you don't have to leave your pound in at the supermarket. To make a simple object, such as this little number plate, it's quite easy to just make it as a one-part pattern which can easily be produced and removed from the sand. It does have sloping sides, it has the draft angle, just like the slope on your sandcastle bucket. Some more complex shapes are difficult to take out of the sand. Even a simple cylinder, once you've buried it in the sand, you wouldn't be able to remove it without breaking the sand, or if you were trying to draw it out vertically, it would break the mould unless you put a taper on it, and then you wouldn't have a cylinder. This can be overcome by splitting the pattern into two parts so that you mould the two parts separately and they locate together using pins in the same way that the pins locate the boxes in the flask. We've already thought about using a split pattern so that you can take the two halves separately. But how can we produce the hole through the middle without having to drill it out? In industry, obviously producing something and having to machine a lot of the metal away is time consuming and cost consuming. So producing it with the hole already in place is an advantage. So we're going to use a pattern. Again, it's a split pattern, but it forms together to produce the outside shape. But it has these locating bosses on the ends, which are known as core prints. They're painted black because that's a visual clue to the people in the foundry that they know they've got to add a core to the mould. So if we take the cope off the top of the flask and set that to one side and turn over the drag, we often refer to that as an inverted drag, and add the first part of the pattern. One side has locating pins, so it sits flat. We'll use the side with the holes face down in the moulding box. This has been set so that nothing touches the sides of the moulding box, and there's a space in the corner for us to complete the moulding work. We give a quick sprinkle of parting powder, and it's just used to help remove the pattern from the sand when we're opening the mould. Because the sand has oil, you may want to wear gloves to protect your hands or use a barrier cream, particularly if you're using reclaimed second-hand sand. We start off by sprinkling the sand, breaking it up as we go, just like making a rhubarb crumble topping. And we partly fill the box. We never fill it in one go. If you fill it in one go, you'll be able to form a very hard surface, but where you need the strength of the mould around the pattern will be compromised. So we just use our fingers to press the sand down to hold the pattern in place. The sand now needs to be rammed down more tightly. This is a typical ramming tool with a flat end on one side and a tapered end to get into corners. I find these are sometimes too large with the small boxes that we're using, so just a piece of broom handle with a tapered end works particularly well. The tapered end is used to get into the corners. You don't need to go crazy. It's not a competition for the world's strongest man. You just add some more layers of sand Build it up, it might take 2 or 3 layers as the sand compresses down. We now need to level off the sand, and that's just done with a piece of bar. The process is traditionally known as strickling, so the tool we use is known as a strickling bar. And if we use a sawing action and take it off a piece at a time, we end up with a nice flat firm surface. And turn things back over, and now you can see we've got the pattern surrounded by sand, and we can just run our fingers to make sure that it is firm. That won't do it any harm at all. We now take the second part of the pattern and locate that in place. We add the cope. We have another dusting of parting powder. This time the parting powder serves 2 processes. Firstly, to release the pattern from the sand, and also to stop the 2 layers of sand from sticking. We need to find a way to introduce the metal into the cavity of the mould. We do that by adding a runner. If we were doing a pattern which needed it, or if you were doing an educational course, you would always need to talk about having a riser, which is a second channel on the opposite side. For this particular task, we only need to have a runner. I use this tapered wooden pin known as a sprue pin, and I place it in the corner of the box. If it touches the pattern, it will damage the outcome. If it touches the flask, the heat from the molten metal will sink out and it will start to solidify before it has completed the task. We repeat the process. Mary Berry would be proud of me doing this. Pressing the sand down and using the ramming tool again to firm the sand. The ramming tool doesn't fit down into the corner, but that doesn't matter. You can use any old thing. I'm using the strickling bar. The sand on the second box, the cope, doesn't need to be quite so firmly rammed as in the drag. We use the strickling bar to strickle off the top the best we can. And then to remove the sprue pin, we just give it a tap, twist it, and because it's tapered, it releases easily out of the sand. I'm going to use a trowel to take the top off around the pouring hole and make sure there's no loose sand, which would wash into the mould. We also produce something called a pouring basin, which makes it easier to pour the metal. It gives you a larger target, but it also reduces the flow rate of the metal going into the mould, so you get less erosion of the sand as you pour. Good practice is to add some vent holes just by pressing in a piece of wire, which allows any air to escape and any small amount of smoke that may be produced by the oil burning out. And we can split the 2 halves of the flask. The patterns now need to be taken out. That can be done just by giving them a gentle tap and then lifting the pattern cleanly out. We've got a good impression in the sand. The same with the other half. That's come out quite well. There's a little bit of looseness there. Nothing to worry about, that can be repaired by hand. We can see there's a small impression on the sand left by the sprue pin. That gives us a good indication of where we cut a small bowl. The final piece of moulding work we need to do is to cut a gate. We know what a gate is. It's where you go into something. Working away from the mould cavity, and we need to ensure that there is no loose sand. A good way of doing that is to blow, and it's sensible to pop on a pair of goggles to make sure that nothing blows back into your eye. So that is the basic mould produced. We just need to produce the core to lay across so that we can form the hole through the middle of the casting. We use the 2-part block, introduce sand, poke it down and ram it to give it some strength. Make sure it's full, trim the top, and then by giving it a tap, it should release the core, which you can carefully lay across the prints. The 2 halves go together, again just checking for loose sand, Okay to pin, put it together, and that's ready for pouring. Because we're going to be using molten metal, we better have a bit of health and safety going on. A leather apron saves any splashes to the body, suitable gloves, and finally a full face visor to keep things nice and tidy. So after a break of 5 to 10 minutes, we now have a pot of molten metal. I'll just turn the burner off. Nice long tongs so that I'm well away from the heat. Just rest it, move the tongs down, and then pour the metal into the pouring basin so that it gently flows. The top of the metal is slightly convex when you first pour it, but as things cool down, the casting contracts, the metal will feed in, and we'll see that it becomes concave and dips in the middle of the runner. It may be that you need to provide surplus metal within the mould so that it will keep feeding. You might have to add maybe up to 50% more metal to the mould than you're going to use in your final casting. Okay, so we've let the mould cool down for 10 or 15 minutes. So hopefully, when we open it up, we'll have the magic of a decent casting in there. It's filled well on the bottom part of the mould. Because we've only used a low temperature metal, the sand hasn't really been compromised. We can now break out the casting. It is still hot. You still have to be remembering that it will hurt you if you pick it up. And then we can just take the sand from the core, just poke that out, and there we have the hole right through the casting, and it's come out and quite nicely aligned on the joints. We just have to cut the sprue off, and that can be remelted for the next job. There's very little waste in the foundry industry. So now we're going to look at die casting. This is a nice simple die made out of MDF laser cut to produce the supermarket shopping tokens. It can be produced out of MDF with a laser cutter, channel for the metal to form and the shape of what you're doing. The two slices that go on the outside of the sandwich, one has got text which has to be in mirror writing, and the other in this case has got a little shopping trolley logo, but there are vents to allow the air to escape as the metal runs in. They locate together and have a board backwards and forwards just so that you've got somewhere to pour the metal. It's held in a machine vise so that it's nice and stable, and we've got a bit of tape around just as secondary clamping so that nothing splays apart when the metal's poured in. And this time it takes quite a steady hand as we're dealing with a fairly small target to pour this metal. And then just to make sure that there aren't any air bubbles, a few gentle taps will hopefully give a good result. Right, so we've given this a few minutes to cool down. I'll just take that little bit off there, and then we can release the tape, undo the vise, and start taking things apart. So we've got the three parts of the die, and they should peel away. Things are still warm inside, so I'll try not to touch the metal, and you can see that the text has formed nicely. Everything's filled well. On the second half, you can see that we've got a nice clear impression of the shopping trolley. Where the air vents ran, you can just see a very small amount of metal just started to go up, but there's no problem with that on this product. It's just a simple matter of breaking them off the main feed, and then a quick touch with the file or a bit of emery cloth will give it the finish that we're looking for. Okay, so just a couple of last safety things to think about. Don't pick anything up without knowing that it's cool. The burner's switched off, but this setup will probably take 20 minutes to cool down so you can comfortably handle it without safety gloves. Don't go and put it in the back of your car. Don't stand it on a table that will be affected by the heat. Things might not look hot, but they probably are. Make that assumption. So I hope that you've learned something from what we've been looking at today. Whether you're watching this as a hobbyist or was thinking about a career in the foundry industry, or whether you're approaching it in a school environment, I hope that you've gained something from it. and have fun, but be safe. Thank you.